Hi everyone. In this video, we are going to go over the answer key for problem set 7. Chapter 7 introduced us to confidence intervals, which is the first way that we can use sample data to estimate population parameters. And so with that being said, as a brief reminder, confidence intervals tells us that the population parameter, such as a mean or a proportion, lies within a certain range of values. And there's four primary steps that we go through in order to calculate a confidence interval. The first is that we have to calculate a standard error. The second is that we have to choose the confidence level and the corresponding z-score. The third is we actually have to calculate the confidence interval itself. And the fourth step is to interpret the results within the context of the problem. So with that being said, let's take a look at question number 1. A survey of a random sample of 1,000 neighborhoods reported an average of 6.2 aggravated assaults in the last year, with a standard deviation of 0.7. What is a 95% confidence interval for the population mean of aggravated assaults? You must show your work and interpret your results within the context of the problem to receive full credit. And so a couple of notes here right off the bat. What you are receiving here in question number 1 are the sample characteristics. So overall, the point of confidence intervals and later what we will do in chapters 8 and 10 with hypothesis testing is to use sample characteristics to make broader conclusions about population data. So what you're seeing here is sample characteristics. So here I see that we have a random sample of 1,000 neighborhoods. So that will be our N, reported an average of 6.2 aggravated assaults in the last year. Our key word here is average. And so that should note for you right away that we are working with means here rather than proportions. Remember that mean and average are really interchangeable terms. And so that should trigger for you that we are using the corresponding formulas for means rather than proportions. Lastly, we see here that we have a standard deviation of 0.7 for our sample standard deviation. I also see here that we are being asked to calculate a 95% confidence interval, and that will be important once we have to determine the confidence level and the corresponding z-score for that. But standard across all confidence intervals, the first thing that we need to calculate is our standard error. And for means, how we go about that is SY here designates our standard error. We need to take our sample standard deviation, which is represented by S, and divide that by the square root of N, which is our overall sample size, which right here from the context of the problem was 1,000 or 1,000 neighborhoods. You see me work out the math here, and you should get a standard error value of 0.022. In terms of our actual confidence interval for means, here's what the base formula looks like. So we have Y, which is our actual mean listed here. So we have the average aggravated assaults within the last year, so 6.2. And then we need to determine in the second step here what the corresponding confidence level is with a 95% confidence interval. You can either look this up on the standard normal table or a z-distribution table. I have a little bit of a cheat sheet for you in the PowerPoint for this chapter because the most common intervals that we will be using are 90%, 95%, and 99%. So save yourself a little bit of time and go and note those corresponding z-values because I won't ask you to calculate an interval for 93% or 97%. It will always be those standard measures. So that corresponding z-value is plus and minus 1.96. The plus or minus here is key when calculating the confidence interval simply because we are creating a range, right? We need to calculate it below our average value and above. And so right here, our job is to simply plug in the numbers now that we have them to do step 3, which is to calculate our confidence intervals. And so I take my average value of 6.2 aggravated assaults a year, and plus or minus 1.96, which is that corresponding Z value or confidence level to a 95% interval, and multiply that by the standard error we calculated in step 1, which was 0.022. Working out the math here, I see I have plus or minus 0.043. And again, we're creating an interval or a range of values here. So remember that you both have to subtract this value and add it. So many of you stopped at this step, which is at the conclusion of step 3, which is great. You still might have actually calculated the confidence interval itself correctly, but there's still one more step, and that is interpreting your calculations within the context of the problem. Not only is that listed here in the actual question itself, but that's also a key step that's listed in the PowerPoints as step 4. And so let's take a look at how we could interpret these within the context of the problem. This is just an example. There are multiple different ways you can go about it, but this is the type of shell formula that I gave you within the PowerPoint. So I'm going to stick to that for now, but there are a couple key features that I want you to keep in mind when creating your interpretation. The first is that you should always start off with acknowledging what level of confidence we have here. This should always align with the confidence level that is stated in the problem. So in this case, that's a 95% confidence interval. So we could say, we are 95% confident that the true population mean, so we're acknowledging back that we have now calculated the population mean here rather than a proportion. Importantly here, and this was a big mistake that I saw on many problem sets in this case, are these 3 words here: true population mean. It's important to note here we started off with sample characteristics, but now we are making generalizations to the broader population. So the key term here is population mean. We have to specifically designate that we are now interpreting this as a population mean. And so this has to be stated clearly to make sure that we are no longer referencing sample characteristics, and now we are making those generalizations to the population. So regardless of how you go about interpreting this, make sure that you include these 3 words here. If we were doing this for a proportion, which we do in questions 2 and 3 below, so you'll see it in just a moment, you would say true population proportion, okay? So we are 95% confident that the true population mean of reported aggravated assaults in the past year lies between 6.157 and 6.243. Okay, that's perfectly fine to stop there. If it makes sense for you to also include this second component, you are more than welcome to do so. Another way to go about stating this, and I wouldn't use this in isolation, your key part here is this first sentence to make sure that you have this part. But to further conceptualize this, you could also think about this in terms of, in other words, there is a 5% chance that the population mean is outside of this range. So think back to the normal distribution or our normal curve, right? The further away we get from our center point of our mean, median, and mode, the less likely or the less probable we are to have a certain outcome. It's still possible though. We could be 95% sure, but there are still outliers that could result in either of those tails. And because of that, even though we could have pretty strong confidence here, upwards of 95%, that true population mean falls within this range, it could be either lower than 6.157 or above 6.243. We are essentially giving our best guess or our best estimate here, but there is a 5% chance that it could be lower or above that figure. So just keep that in mind. Okay. Let's move on to question number 2. A city police department receives reports of a rise in unreported property crimes in a particular neighborhood. Because conducting a full census of households is not feasible, the department decides to estimate the proportion of households affected by using a survey. Investigators randomly survey 102 households in the area, and 19 report having experienced a property crime in the past month but did not file a report. What is the 90% confidence interval for the proportions of households in this neighborhood that experienced unreported property crime? You must show your work and interpret your results within the context of the problem to receive full credit. So let's first take a look at the information that we can pull out of the problem here. Again, these are the sample characteristics. Starting off, our N value, or the total number of households that the investigators are surveying, is 102. There isn't necessarily a clear proportion value here, but we know that we can easily calculate a proportion by simply taking those that reported having experienced a property crime out of the total number that are within our sample. So that proportion is 19 divided by 102 to get 0.186. Additionally, I know from seeing within our sample here, we are now calculating a 90% confidence interval. We also have proportion listed here, so that should be a key for you that we are switching from means in question 1 to proportions here. So it'll have a couple implications for the types of formula and the different calculations we'll be doing in a couple steps here, but just keep that in mind. And so with a 90% confidence interval, our corresponding z-value is 1.65. And so we'll keep that in mind once we get to the later stages here of actually calculating our confidence interval. You'll see here in step 1, where we need to calculate the standard error, that calculating the standard error for proportions does look different than calculating the standard error for means. So that's why it's important when you first read the question is to determine whether or not you are working with means or proportions. Essentially, that's the first thing you should do because it's going to determine what type of formula you are using. So our standard error formula here is to multiply the proportion value times 1 minus the proportion value over n and take the square root of that entire figure. And so here is me working through the math here. And you should get a final result of a standard error value of 0.0385. So now that we've calculated the standard error, we can actually plug that into our confidence interval for proportions. We already have our p-value here from what we calculated and pulled this from in step 1. So all we have to do is plug in our corresponding z-value to the 90% confidence interval as well as the standard error that we just calculated above. So when I do that, I can take 0.186 plus or minus 1.65 multiplied by 0.0385. Here's me working through the next couple of steps here in terms of the math. Again, recall that you have to both add and subtract this value because we are creating an interval or a range. And so our total confidence interval for proportions in this particular problem is 0.123 and 0.250. And so if you stopped here, you successfully completed steps 1 through 3, but again, we have to interpret our results within the context of the problem, or step 4. What does this actually mean for us in the context of this problem? Again, if we were just to report these numbers, that doesn't really mean anything to the general public or the investigators. And so we have to provide the context of what this actually means. And that's what we're doing here in step 4. So following the same shell of the interpretation that we even did for question 1, let's take a look at how we could interpret this with question 2. We are 90% confident that the true population proportion of households that experience property crime but did not report it is between 0.123 and 0.25, or 12.3% and 25%. In other words, there is a 10% chance that the true population proportion is outside of this range. And so overall, the structure of this interpretation should look almost identical to the one you saw above, with a couple changes that makes it relevant to question 2. So here you see that the actual interval changed to 90% because in this question we are asked to perform a 90% confidence interval rather than 95. And here we are using our three key terms of true population proportion. Again, because we are using proportions rather than means. Again, key term here is population because we are switching from sample characteristics to now extrapolating that out to make conclusions about the population. So again, key term here. Of households that experienced property crime but did not report it, again, between 0.23 and 0.25. You could also convert this into a percentage. Oftentimes percentages are a little bit more easy for us to interpret in this context, so that's perfectly fine. And then again, this isn't necessary for the interpretation, but if it's easier for you to include this, you are more than welcome. In other words, there is a 10% chance that the true population proportion is outside of this range. So again, those outlier values could still happen. It's a low chance, but it is still possible, right? An outlier value could still occur. And so, like I said, very similar setup here with a few modifications just to have this be relevant to question 2 in that material. But again, same type of shell here. Let's move on to question number 3. According to a survey of 325 police officers, 33% report symptoms of anxiety and depression. What is the 99% confidence interval for the population proportion of police officers who experience symptoms of anxiety and depression? You must show your work and interpret your results within the context of the problem to receive full credit. Okay, let's pull out the information about the sample characteristics here right off the bat. Unlike question 2, where we had to actually calculate what the proportion value was, we are given an actual percentage here. And so we know that we can move directly from a percentage to a proportion by simply dividing our percentage value here by 100. So our proportion value is 0.33. Our N for our sample is 325 police officers. And lastly, for a 99% confidence interval, the corresponding Z value is plus or minus 2.58. And so first, similar to question number 2, we have to calculate the standard error for proportions. So here we take 0.33, which is our proportion value here, multiply that by 1 minus our proportion value of 0.33, divided by our N of 325, and we take the square root of that value to get a standard error of 0.026. Again, our base formula here for confidence intervals for proportions is P plus or minus Z multiplied by our standard error. And so once you go and plug this in, this is what your formula should look like. Once you go ahead and both add and subtract those values, you should get a confidence interval for those proportions to be 0.263 and 0.397. So the last step here again is to interpret our results within the context of the problem. So we start off here by stating what our confidence level is. We are 99% confident that the true population proportion, again because we're using proportions rather than means, of police officers who experience symptoms of anxiety and depression is between 0.263 and 0.397, or 26.3% and 39.7%. In other words, there is a 1% chance that the true population proportion is outside of this range. Importantly, when you are working with proportions, if you choose to report these as percentages, please ensure that you are still keeping intact this 10th position here. If you rounded this to just 26% and 40%, that is a lot less precise than our proportion values listed here. So just make sure that you are having the most precise estimate that you can. Don't round it to the whole number here. And so with that being said, that is the overview of our problem set 7 for confidence intervals. If you have any questions, please feel free to email me or stop by my drop-in hours or set up an appointment with me. Again, the key here was really just interpreting the results within the context of the problem. Otherwise, a lot of folks actually did steps 1 through 3 very successfully. So I encourage you to take a look at step 4 again, particularly slides 22 and 28 of the PowerPoint for chapter 7, because it has examples of how you should interpret your results for both means and proportions. Also, take a look at how this problem set interprets them as well. This is the kind of language that I would be looking for in your upcoming quiz and any future problem sets that may have to do with interpreting sampling characteristics and populations. And so with that being said, again, if you have any further questions, please let me know. And as always, I will see you in the next video.